Hi everyone. In this video, I'm going to show you how to use a three-point problem to determine the strike and dip of a planar bed. Here's the problem we are given. We have a topographic map and there are 3 points, A, B, and C, where we are told that the top of a shale layer that is planar is exposed. And we need to use these 3 points to determine the strike and dip of this layer. For this problem, you're going to need a protractor, a calculator, and a ruler that is long enough to span your entire map area. So let's get started. I'm actually going to put a piece of tracing paper over here because I'm going to layer a few things onto this problem. So to start off, first thing that we're going to do is write down the elevations of our 3 points. So we're given A is 40 meters, B is 60 meters, C is contour interval is 2.5 meters, so C is 75 meters. The next thing we're going to do is write down what our scale bar is. All right, so we have a 50-meter scale bar here, and we'll measure it and determine that that is 8 centimeters. So we have 8 centimeters equals 50 meters. Okay, so the first thing we're going to do is, based on our 3 points, we are going to find the highest and the lowest point, which are A and C. And we're going to draw a line connecting these 2 points. Okay. So remember, this is a planar shale layer. It's exposed at these 3 points. What we've done is found the highest and the lowest layer, drew a line between them. What we know for sure is that the elevation of point B, 60 meters, the elevation must pass somewhere along this line for that shale layer. So step 1 is to determine the elevation difference between your highest and your lowest point. So we have A to C. It's going to be 35 meters. The next thing you want to do is determine the elevation difference between your highest and your intermediate point. So that's going to be C to B, which is 15 meters. Okay, so now we know that these have 35-meter elevation difference, and from C to B, we have 15-meter elevation difference. So what we need to do then is figure out how far along this line will that elevation be. Okay, and to do that, we are going to say, okay, well, what proportion of 35 is 15? Just 15 over 35, right? And that equals 0.43. That means 43% of the way along this line, we will hit the elevation equivalent to point B, right? 0.43. So now all we need to do is figure out, based on this distance, what's 43% of the way across. So now we're going to measure that line. I'm getting 12.5 centimeters. So A to C, 12.5 centimeters. So what's 43% of 12.5 centimeters? That's going to be 12.5 times 0.43. So that's going to tell us from C to B, it's going to equal 12.5 times 0.43, which is going to equal 5.4 centimeters. So I now simply need to measure 5.4 centimeters from point B. Find that point right there, which I will call B prime, right? This point here represents an elevation of 60 meters, okay, which is the same elevation as point B. So what we have now are 2 points that are both at 60 meters, and because we have 2 points of the same elevation, that means we can draw a line between them, and that is a strike line or a structural contour. I need to use my longer ruler for this. So 2 points at the same elevation define a line or structural contour of 60 meters. Because this is a structural contour, it is a strike line, we can just use this to determine the strike of this bed, right? All we need to do is measure with our protractor the angle of that line with respect to north. The first thing that we need to do, because we could measure two different directions here, is we need to figure out our dip direction. So because we know that C is higher, B is intermediate, and A is lower, that tells us that this bed must be dipping towards A, right? Because A is the lowest elevation. And using right-hand rule, if it's dipping towards A, that means that this is going to be our strike direction. So I'm going to go ahead and measure that angle with respect to north. I have a little bit of glare coming in here, so pardon me if I stick my head right in the way. Okay, I'm getting about, let me move that in a little bit. So that's going to be 75, 76 degrees coming in that way. So that's going to be 270, 280, about 285 degrees. So our strike is 285 degrees. So we got our strike, and we got our dip direction, which is that way. So now we need to figure out the dip amount. And for that, we need to turn to trigonometry. So we're going to do that is we're going to use this equation, that is the tangent of dip is going to equal the change in elevation over horizontal distance. So the first thing that we need to do here is we need to draw a perpendicular line from our strike line, because remember, dip is always perpendicular to strike, that connects point A to our strike line, and it has to be perpendicular. I'm going to draw that line just like that, perpendicular, okay? So I know that this point here is at 60 meters, and this point here is at 40 meters. So I could start drawing a right triangle like this. This is 60 meters, this is 40 meters, right? So that means that the change in elevation here is 20. We can go ahead and put that up here into our equation, 20. So that's the change in elevation. This is 60 meter contour, 40 meter contour, 20 meters difference. But now we need to figure out what that horizontal distance is, okay? And for that, we're gonna need to convert using our scale bar. So what is that distance in centimeters? We've got about, looks like almost exactly 7 centimeters. We'll call it 7 centimeters. And we need to figure out what that is in map units. So 8 centimeters equals 50 meters. That means 7 centimeters is going to be equal X meters. We're going to cross multiply. We'll go 8X equals 7 times 50. I'll grab my calculator and do that really quick. 7 times 50. So 8X equals 350 divided by 8. That's giving us an X distance of about 44 meters. So that's what we're going to put here. That's our horizontal distance. So now we can solve this for dip. We'll go 20 over 44, and then we'll take the tangent, the inverse tangent of that, and we will get a dip of about 24 degrees. So our strike is 285 degrees. Our dip is 24 degrees north. And that is how to use a 3-point problem to solve for strike and dip. The next thing I'm going to do in the next video is we are going to use this strike and dip to draw structural contours, make a structure contour map for this whole map, and we will determine the thickness of the shale unit and draw an outcrop pattern. I'm going to make a new video for that.